Hey guys, Seton HVAC back with another video. That was a impersonation of Long Island Audit. I'll do another one here in a second, but happy Thursday, guys. Kind of just sitting on my hands, a little slow right now with installs. Just waiting for any service calls to come in, so I figured I'd take any chance that I get to train the upcoming technicians and installers and whoever else wants to get into HVAC. I take a lot of time, not just here on YouTube, but in my community and my personal time with lots of people, trying to spread the knowledge and the experience that I have to help out in our trades. Because once we're gone, I don't know what we're going to do. It seems like the HVAC guys are getting older and older. Every time I look around, not many young kids are getting into it. Not the way they flooded it, 40 years ago. That's for sure. So today I'm going to show you guys the most basic components that you'll run across if you're a new kid, a new tech. What they do, how they operate, how to troubleshoot them, and basically just getting familiar with them, which is the most important thing. Once you're familiar with something, it's like second nature when you approach it on a customer's home or on a commercial building or wherever you may find it. These few basic items will bail you out on a lot of things you encounter. So anyway, I really enjoy doing stuff like this, and I hope you guys appreciate it. It's really hard. A guy made a comment that he doesn't like my shorts that I do, and I made a point to him, hey, these are just snippets from videos. And he goes, well, you don't put a link to the video. I go, well, it'd be pretty easy to figure out because I usually do the shorts in the evening after I post the video of the day. So they happen on the same day. So, take the extra 2 minutes, come off of the shorts run that you're on. I know you got short attention spans, boom, 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 but go out of there, search Seton HVAC in the search bar on YouTube. My channel will pop up, and it'll be today's video, and then you'll be able to see whatever information you're missing. It's that easy. I take a lot of time, out of my busy schedule. Running an HVAC contracting business, being a one-man band is no joke. Raising a family, upkeep on the house. I got up early today and I mowed my entire huge lawn. It's a pain in the ass. I did some trimming, so it's my day off, so I'm trying to make the most of it. And there needs to be more appreciation for what some of us do, because I appreciate all the other HVAC YouTube channels, whether we get along or not. I know it's a lot of hard work in addition to the hard work that you already do. So enjoy today's video, guys. Thanks a lot, and I appreciate it. All right, guys, here's the old rundown. Here's the best tool. I got my Seinfeld coffee cup filled almost to the brim with coffee. That's what you need first. But we have our capacitors. We have this is a 50-year-old dual capacitor that still works, still holding its capacitance, just as good as the day that it was made. And then I got two newer ones here. I have a dual run capacitor that controls the fan and your compressor, Herm compressor. And then I also have a regular, just a fan run capacitor. So it's just going to have the two terminals on it. Then what we have is a contactor. Some call it a compressor contactor, and I'll show you how we test those out. Somebody was nitpicking that I didn't go over this Focus Pro very well on how to wire it up and what it does. So we're going to go over that. And then I have 4 different types of breakers, and we'll go over what each one does, how to be safe with them, and how to check power, how to diagnose if you have a bad breaker or not. And then the basic old float switch, a 2-wire float switch. They come in many different shapes and sizes, just the one I have here. And I'll show you how to troubleshoot your basic float switch. If it's called a float switch, they're all going to work the same way. So this will fit for any float switch you run across. Okay? So let's do the rundown here. Let's go through each of these, and I'll show you how you test them. Okay, let's start with the old capacitors here. So how do we test these guys out? And I was wrong. Sorry, this wasn't a dual capacitor. This is just a compressor capacitor here, an old Herm capacitor from a 52-year-old unit that I pulled out a while back. So you can see the numbers on that. 35 microfarads. 60 hertz, 370 VAC, same way they make them today, except today they do them dual VAC on most of them. Actually, these are 370 VAC, these Protex, and then these Mars are 440 VAC. So anyway, how do we test these? So let's start with the old guy here. Let's get that. That's close enough you can see. So you have two sets of terminals on this, okay? You got common, and you have herm, your compressor, your hermetically sealed compressor, okay? So what we're looking for is we're looking for 35. So let's grab our meter, and I'll show you how you test that. Okay, first thing you want to do is take your meter, and you want to put it on MFD. That's your microfarads. That is your measure of capacitance, okay? Some meters will have the symbol. And honestly, I could have drew you a picture, but do a Google search of a microfarad symbol, MICROFARAD symbol, if you have a different meter that has that, and that's where you want to put your dial on. So you flip that over, and it's going to read at the bottom. It's going to, well, there's your symbol. Or let's see if we can read this. See, you can't, that blue doesn't come up on camera. I don't know why. But see that little symbol right there? That's your microfarad symbol. Okay. And then you got a range here. You can have it, the decimal point move over, but for this purpose we don't need to do that. So we'll leave it just like that with the decimal point there. Okay. Boy, I sure wish it showed up on my phone. Here, I'll just kind of leave it like that when we do this, okay? So let's go over to our capacitor. It's right here. 35 microfarads, okay? Let's back this back out a little bit. Okay, as far as we can go. You want to take each of your leads. It doesn't matter which goes to which. And we're going to punch those on there. And why is that not reading? Is it because I moved my... See, this is why you... Oh, right, hold on. There we go. Oh, it's calling me a liar. It's going to call me a liar. This was good when I pulled it out. If you guys saw my video from a while back. Hold on a second here. Range. Don't ask me why that's not reading anything now. Let me go over this here real quick. Sorry, guys. All right, let's go back over here. Okay, so that's interesting. That's very... Oh, there we go. There we go. I don't know why that wasn't working. 34.9. 34.9 on a 52-year-old capacitor. So one of these is going to be on a single capacitor like this. It's just that you're just testing one. It doesn't matter what side your leads go on, because one side's going to be your common out and one side's going to be your component. So there you go, 34.9 on a 52-year-old capacitor. Lovely. Okay, so that's how you test that. Now let's go to the, let's move this over. Let's go to the dual capacitor, dual run capacitor. So this one does our hermetically sealed. You'll have one terminal that's labeled herm, which is right here, and then you'll have one that's labeled common, which is right here, and you'll have one that's labeled fan. So what you want to do is you want to take your leads again. Let's leave that up there so you can see what we're doing. And you're going to go from common to fan. So this is a, hold on, let's go over what this is first. This is a 40 plus 5. That means it's 40 for the compressor, 5 microfarads for the fan. Sorry guys, my mind's a little spacey today, so I'm stammering a little bit. Not enough coffee. So common and fan, it'll say so 5.12, so we know that's good because it was calling for 5. And then we're going to go between common and our herm terminals, and that reads 42, so we're good. And that actually, it's almost a little high. It's got a 6. So another thing you'll see on these is they have a tolerance, plus minus 6%. So, you know, you figure out what 6% of 40 is. Top of my head, that's 1/6. you know, that's 2 point something. So we're pretty close. We're within 2 though, so I know it's probably not, because I know it's higher than that. It'd be like 2.6 off, so we have to be closer to 43. So, but that's kind of weird. This one's got a little bit too much capacitance. It'd be, you know, once it starts getting closer to being a 45.5, it's not gonna work well for a one that's calling for a 40 plus 5. And then lastly, we have our single fan run capacitor, and that'll just have one number on it, your 5 microfarads. Again, it's a plus minus 6%. Let's test that out. And again, on these ones with 2 terminals, it doesn't matter what lead you put on what. And 4.99, we know that that's good. So there you are. Let's move on to the contactor. All right, I got set up a little bit better here. So next on our list is our compressor contactor, or we can just call it a contactor. So what do these numbers on here mean? Okay, so we have our coil loads, right? So it's a 24 volt VAC volts AC coil, which is back here. It's inside the shell. That's your resistance. That's your contactor coil. And then what you have is your hertz rating on it: 50 hertz, 60 hertz, general stuff there. And then on here we have our VAC volts AC, 240 volts, and that's what this is here on the bottom. This is what these numbers are for. Then you have your full load amps, which is it's a 30 amp contactor. Your locked rotor amps, 180, and then this is your resistive. Gosh, I forgot what that meant. Resistive amperage. No, sorry, resistive. RLA, resistive load ampacity. There we go. Resistive load. If you really want to know what that means, HVAC school, go on there and just search RES, and it'll tell you RES for a contactor. If you really want to know what that means, that basically it's different than what your full load amps would be. This number is always higher because it has to do with the terminals themselves, not for the coil. Your coil only has a voltage and then your hertz readings that are pertinent to it. All these numbers here are pertinent to your 240 volt terminals and your switch. Okay, has nothing to do with the coil. That's why they put these numbers down here. It tells you what to torque your screws to and stuff. Whatever, just tighten it real good with your screwdriver. So how do we test? So this is what's called a 1.5 pole, and why it's 1.5 is because you never lose power based on this switch through this side, but you will on this side. So it's basically just interrupting 120 volts here, but it's not interrupting this. This stays hot all the time. Okay. So when this energizes, when this energizes 24 volts, you have a hot side and a common side. And they're interchangeable. You're always gonna have 2 wires there. Usually they're yellow and blue, I think, depending on what type of equipment. Some are yellow and brown, based on what they use for common. But typically it's yellow and blue or brown. So when this energizes the coil, pulls this in, and what that does is that shunts your I shouldn't say shunt, is that allows your 120 volts to flow to the top here, and that'll energize your equipment, because now you have 240 volts coming out instead of just the 120 that's always there. If this was a 2-pole contactor, these would both be interrupted per the switch, okay, per the button that pulls in. So that's the basics on that. Hopefully I explained it well. I'm not the best at explaining this stuff. I'm good at working on them. But yeah, if there's anything I missed, let me know, you keyboard warriors out there. But that's basically that. They'll tell you how it works. Oh, and then we also want to test the resistance on the coil, okay? And we're going to test that between these two. So what you do, let's say you walk up on a piece of equipment, you pull your 2 low voltage leads off. Make sure they don't touch anything. If you don't feel comfortable doing that with it live, go inside and shut off your indoor unit. That'll kill the 24 volts coming to the coil. Okay. Or you could also take Y and common wires coming into the heat pump or AC, and disconnect those. Just disconnect the wire nuts and just make sure they don't touch anything, obviously, and then you're not energized. Pull these off, and yeah, you don't want load on the coil as you test it. So what general rule of thumb for me It's almost like a good superheat reading on an air conditioner. I think between 8 and 18 ohms works well. It's a good rule of thumb. Anything out of that range, usually if you have a dead coil, it's going to give you a real low number, and you know it's bad, and the equipment's not working, so it's pretty obvious. So let me show you how we do that real quick, and then we'll move on to the next thing. It's going to be a long video today, I think. All right, so we're still on microfarads from testing the capacitors. Now for the contactor, what we want to do is we want to switch this over to ohms. So you want to switch that over to your little ohm symbol, which is that symbol right there. Okay. Some meters actually will say ohms, makes it really dummy proof, but that is your ohm signal right there. So what we're going to do is we want to test. Let me put this back. I just want you to be able to see the number there, which you can. I wish I could turn it on bright blue. So then what you're going to do is you're going to take your contactor and you're going to go from one side to the other. That's all you're going to do. And that reads 14.6. So that's good. You know, it's my rule of thumb. I know some guys are different. I've had some that are lower than 8 that were still working, but might be a good idea to replace it. Yeah, 14.6. Let me show you where I put my leads. One there, and then one on the opposite side. That's your 24 volt side, and that'll read your ohms for you. Anything in the teens is pretty much good. You start dropping below 10, it might be time to recommend a new coil. A new contactor to the customer. You may disagree with me. Somebody's going to get on and say, "Oh, dude, six ohms is fine." You know, but you're not going to find anything above 20 usually on these. So anything in the teens is usually good. Good rule of thumb. I say 8 to 18 because I haven't found any that are over 18. Not on the stuff I work on anyway. So all right, let's move on to breakers. All right, we're going to give you a little overall here of this breaker, and then we're going to get really up close and personal because they really put the writing hard to see on these. If you're hard of seeing, if your eyesight's not good, you'll need a magnifying glass or have someone else read it for you because these are really hard to see. But this is what's called a two-pole breaker. Double. Usually guys will say single or double. Let's use the right terminology here. Let's not. Sometimes when I'm on video, I say stupid stuff. What can I tell you? So this is what's called a double pole breaker. Okay, 240 volt double pole breaker. So the reason why is you have two poles. One pole here, another pole here. Each one is 120 volts. Together they're 240 volts. Okay. So on the bottom of the terminal you have 120 volts here, 120 volts here. 240 volts, okay? This would be for like an electric furnace, an air conditioner, a heat pump, a fridge, a dryer, a range, something that requires 240 volts in the home, okay? Something that produces needs a lot of power or makes a lot of heat, okay? And well, like a hair dryer needs more amperage. That's why bathrooms are usually 20 amps because, you know, your wife hooks your hair dryer up. So, yeah, something that produces heat usually needs higher amperage and not necessarily voltage, okay? So, this is a 30 amp. See the 30s on there? It's a 30 amp two-pole breaker. So, you got your 120 volts here, your 120 volts there, 240 volts. When you flip this up, you now energize these terminals. So, when this down, the teeth that go into your breaker panel, this is 120 volts here, 120 volts there, 240. With this down, you're broken to your terminal, so you can work on it or you can test it. Okay, so let's say you got your meter on there, and you flip this up, you should have 240 volts here. If you do not, you got a problem with this breaker. Always, always hire a licensed electrician, of course, but, sometimes in HVAC, we got to troubleshoot stuff. We don't have time to wait for somebody. We've got to get a customer's heat going. So you need to know how to work on this stuff. Whether the municipalities like it or not, they're not the ones that are sitting in the cold for a couple days because the customer can't get a hold of an electrician. So that's the basics on these. It's a double pole, 240 volt. So let's get this guy up close and personal. Let's show you these numbers on here. All right. So what we have is amperage 10 to 25, 30 to 35. I don't know what that first number means. If you guys know, tell me. 10 to 25, 30 to 35. I don't know what those two numbers mean. You know, it's supposed to be a tutorial. I guess I should have done my homework on that. But it's telling you what gauge of wire you can put in there. 14 to 8, 14 to 6. I'm assuming what it's telling you is that's your minimum and then that's your maximum, okay, on your amperage, and then that's your minimum and maximum on your gauge of wire, and then it gives you your inch pounds that you want to torque them down to, 25 inch pounds of torque on your wires. 2-pole type QP, that's just the brand Siemens. It gives you an interrupting rating, maximum RMS amps. You know, you'll never really need to know what all those little numbers mean, and you really don't need to know what these ones mean if you're just working on it. But for somebody installing these, they want to definitely pay attention to what's the numbers that are on these breakers. So there's the first breaker. I won't get into fine detail with these other ones. I just want to show you what the other types are. So let's move on. All right, here's another breaker. This one's a little different. This is what's called a quad breaker. So what you have is you have one circuit on the outside, which is a 20 amp 240 circuit, and those terminals are the two outside terminals. And then you have, you know, just like my other one, a 2-pole. It's basically, they're both 2-pole breakers. You don't want to flip one of these up without the other one. You could. Actually, you know what? You can, because this. So I said it wrong. This would have a bar across here conjoining these. So what you have here is you have a 120 volt circuit, 120 volt circuit, like lights and plugs, a garage, and then your heat pump or AC, you know, here, or a range or whatever, which is 240 volts. So you got 120 volts, 240, 120, and then you'll notice that there's I guess you can't see the teeth. All that must all be done internally inside the breaker, but you still have 120, 120, and then 240 there. They just do it differently on these. But yeah, there's your quad breaker. If you needed to minimize and be able to fit some stuff, if the panel didn't have room, this is a breaker that they would use, just so you know what you're looking at. So, you know, this will usually be labeled lights and plugs for something, and same with this, or like a microwave maybe. And then this would be your, you know, more appliance that takes more power, range, dryer, HVAC equipment, you name it. So there's that one. All right, so here we got a standard square D breaker, 20 amp. It's still a double pole. It just has the switch is different. It doesn't have two sides to it, and it's just the way they make these ones. You know, but it's still 240 volts, just like the other one. It's got one. They mount different into the panel. So this is your 240 coming in. This actually is just to mount it in the panel. There's no power here, obviously. That's just the way they clip onto the bus bar on the panel. But same thing, 120 volts, 120 volts, 120 volts, 120 volts to your panel. So another type of 240 volt breaker. And then I'll show you the last one, the simplest of them all. This is your standard single pole 120 volt breaker. It's another square D one. It's got the weird clips on it. This one's energized. This one's not. This just mounts it on the bus bar. 20 amp. So it's just 120 volts in, 120 volts out. And again, it'll have some fine print with its ratings on it. If it does not, then you would just look it up per the number on the breaker, and try to figure out what your specs are on it if you need to know. Like in our industry, you usually don't need to know. Call an electrician if there's an issue, or if you need any information, and they will tell you. It's a QO. These are your square D QO, 120 volt single pole breaker. Let's move on to that thermostat. That'll be more fun than this. I'm probably boring you with the breakers. All right, guys. So here I got my my Focus Pro, Honeywell Focus Pro thermostats. These are the ones that I install now on every project. I've had really good luck with them. I haven't had a single issue with them so far. So I like them. You know, some guys will say they're ugly, and they're basic looking, but you know what? It's not supposed to be something to brag to your friends about on the wall. It's supposed to be something functional that keeps your family comfortable. So let's run over the components of this, and what they do, and how you install. Well, I'm not going to show you how to install it. It's pretty basic. It's 2 screws and some wires, but I'll show you where everything goes and try to show you how everything works on it and what each function does. So let's do it. All right, so here it is. It's the Focus Pro P200. Let me turn that over. It's English. Programmable thermostat, does heat pump and conventional, does up to 3 heat, 2 cool heat pump, up to 2 heat, 2 cool conventional. It's the TH232 OU 4006. That's my go-to thermostat. So when you open up the box, here's what it gives you. It gives you your little backing plate. It gives you your little plate that your thermostat wires are going to mount into, and I'll show you what all that does. This is your face plate that pops onto your little terminal plate there. It gives you a beauty ring here. You know, if you got a larger old thermostat, you know, if you're pulling off like an old Chronotherm 4 or something, you'll need this to cover up the boo-boos on the wall. Yes, I said boo-boos. Then you got your 2 AA batteries that it uses to power. If you do not have a common, I recommend a common. It comes with a user guide, installer guide, and some wall anchors and screws. These actually aren't the ones that I actually stole out of this, but it comes with actually 3 heavier duty anchors and 3 screws, but it'll always have those in there. So what do we want to go over first? Let's go over the terminals on this guy and how all this goes together. Okay, typically the first thing you're going to do on these before you do anything else is you're gonna mount this guy on the wall. You know, you're gonna mark, make sure it's level on the wall. You're gonna mark there, and either top or bottom because it gives you 3 anchors. Mark that, pull this off. I usually just take my little thermostat screwdriver and pop it through the drywall and just kind of wobble it a little bit. Pop your little anchors in there, and then pop this down, put your screws in, good to go. Real nice way to doing it, then you're all set. And then the next step is, let me show you in a second. Alright, so then your next step is going to be to take this guy, and then you're going to clip the top, so he just kind of hooks on the top, and then you just push the bottom, and that pops on. So now it's all one piece. So we're envisioning this on the wall, okay? So then, once you do that, you should have your thermostat wires should have been pulled through this hole already. Don't let them fall inside the wall. So you have all your thermostat wires here, okay? So let's say we're installing a 2-stage heat pump, a 2-stage compressor heat pump, and a single stage backup heat, like electric backup heat and an air handler, okay? So here, let's go over these terminals. Ugh. Let me get this set up better and I can go over the terminals. All right, so what do we have here? From top to bottom, we have R, C, and R. Typically, you're just going to wire into R. And these are nice. These are little push-in terminals. You just push that down, push your 18-gauge thermostat wire in there, and then release that, and it catches, and your wire's locked in there. Make sure you push it in all the way. K is not used. W, that's not going to be used for heat pump unless it was a 2-stage. And actually, no, that's never going to be used for heat pump. Never mind. You have your E for emergency heat, and you can actually set this up in the programming to have E and auxiliary. See, it says E and auxiliary. You can have those powered at the same time, which you're going to have in most cases. O/B, that's your reversing valve. That's for nothing that you're going to use. It's for like a monitoring light or something. You got your U and U if you got some contacts there for like a humidifier or an accessory. You got your common. You got your G, that's your fan. You have your second stage compressor, which is Y2. You have your first stage compressor, which is Y. And then if you have an outdoor sensor that you want to add to the system, that's what these terminals are for, S and S. For staging your backup heat if you want to set a lockout temperature or something. Okay, so red goes there, red R. Auxiliary is always going to be white. That's your defrost / emergency heat. All right, so that's your terminals. So yeah, that's how that goes. You get everything pushed in there, and then shut that. Okay, just like so. And then you have your here. We'll go back to the bottom here. All right, so you'll have it shut like that. You'll take your face plate, push them on there, and there's your finished product. Now, let's say you have a wall that's got a little damage on it. You're going to take this guy, flip him around, and he just clips on there. Okay, that's your little trim ring. And then you push him down. Just like that, and that's your finished product. And then you got a nice clean wall there. Let's put some batteries in him, and I'll show you how we program it. Alright, let's go over how we program this guy. So first thing, this one I already programmed, so if you ever get in that situation where you need to go back into the settings, you're going to hit the up arrow and the bottom lower left button for 5 seconds. And that'll get you into your initial setup phase here, your ISU. So, let's go through it. So I wish the backlight stayed on longer for these. That's my only complaint. So let's hit our select button, which is the bottom here. Right. So select. So there's your first function, 1040, which if I look at my book here, that is your scheduling options. So 1 would be 1 week, all days are the same. 2 would be 5 days, like your Monday through Friday would be the same. 2 would be different. 3 would be a 5-1-1 if you wanted to have Saturday and Sunday different. 4 would be 7-day programmable. I'm just referencing the installer guide over here. I'm not gonna put it on camera because you don't really need to. So 1040 would be I leave it at 4 because I want 7-day programmable typically. For me, if it was me, that's the way I do it when I install them. Get that light out of there. Stupid light. Here, let's turn this a little bit more. God dang, it's hard to get this right sometimes. Here, let's leave that at an angle there. God damn it. I'm telling you, the lighting, I need to work on my lighting here in the shop. Let's light that back up there. Now you can kind of see that better. Alright, so we'll lock that in. So you go to next. And 1050 be temperature scale. I mean, here in the States, United States, we're going to be Fahrenheit. If you're up in Canada or in Europe, you're going the Celsius route. And I can show you can just hit that up and down arrow, and that'll toggle between C and F. You're going to leave an F around these parts. 1060, that's whether or not it has an outdoor sensor. If you're using it, one of the 2-wire sensors, and this does work with the same 2-wire sensors that the old Vision Pros and the Prestige thermostats used. 0 would be no outdoor sensor. 1 would be wired outdoor sensor, meaning you have the 2 S terminals wired in. And then it's also got a, well, if it was the Wi-Fi, it would have a 2 here, and it'd say internet only. Internet would control the backup stages. So let's go back out of that. Next. So we're going to leave that at 0. And then 2000 would be your heating system type. It's 1 is conventional forced air heat if it was a gas furnace. 2 is a heat pump. 3 is a radiant heat. Like I said, this one's been programmed, so it's going to be on what I set this one up as. I had to pull it off the wall because the customer wanted a different one. They wanted something that they wanted the Wi-Fi thermostat. So 3 is radiant heat. 5 is none. That's if it's just an electric furnace. You'd bump that to 5, or just like an electric furnace that doesn't have any cooling. But since we have a heat pump, we'll go back to 2. 2010 heating equipment type. 1 standard efficiency gas forced air. 2 is high efficiency gas forced air. 3 is, let me center that better. Stupid thing. Alright, sorry about that. Bumped the off button on the phone. Alright, so 2010, yeah, 7 is air-to-air heat pump, 8 is geothermal heat pump, 9 is hot water radiant heat, 12 steam. So if you just toggle through, it's just got those numbers, jump. And this one actually, this one doesn't even go to radiant heat. I don't know why. Probably because from one of the settings already. Oh, because I already said it was a heat pump heating system type. So if we were to go back and let's say it was, you'd go to 3 and call it radiant heat. That would unlock your 9 and 12. All right, that makes sense. But we're going to go back to 2 since it's a heat pump, and then it's an air-to-air heat pump, so that would be 7. Leave that there. And then reversing valve, like the Bosch I install, Rheem, are B, so you would switch that to 1. A lot of other systems it energizes on O, so you would leave that at 0. Compressor stages, that's pretty self-explanatory, 1 or 2. This is a two stage compressor, let's say. So you can put that at 2. And your backup heat, we have 1 stage of backup heat. If you had 2, you can toggle it to 2, but it won't do that on this because I already have 2 stages of compressor. So it'll only do 1 because this only does up to 3 stages. Auxiliary E terminal. Okay, so 0 is to drive them both together. Remember I was telling you that it does that. If you want them separate, you wanted your emergency heat separate from your auxiliary, then you hit that 1 and that breaks up that so they don't drive the voltage to both terminals at the same time. Backup heat source, 31 is electric forced air, which is what I have. If you had gas furnace as your backup, you'd switch that to 32. If you had a high efficiency gas forced air as your backup, you switch that to 33. Then there's also oil forced air, hot water fan coil, hot water radiant heat, different terminals there. We're going to leave ours at 31 since it is electric. System changeover, auto, manual or auto. That just determines whether or not it shows both heat and cool on your main screen instead of just showing one at a time. You'd have to go over and switch the function. It'll toggle between the two based on what your set temps are. Let's take a break here and we'll come back to this. All right, 3015 is your auto changeover differential. 3 is the what it comes out of the factory as. So that's what you want to put it at. You want to make sure it stays at 3. You don't want it cycling back and forth between heat and cool. So you want to leave that at 3. Let's see, finish with high cool stage. I usually just leave these all on no because you don't want it going into it if it doesn't need to. Same with your finish with high heat stage, which is 3021. Leave that at 0. Your backup heat droop, just leave it at 0. That'll leave it at comfort because you don't want to be uncomfortable in your house. You don't want it doing all kinds of weird stuff. Upstage timer for backup heat, I leave that off. I don't want it upstage into the backup heat if it's not needed. If if the thermostat's not keeping up, you didn't get a properly sized heat pump. That's my opinion. And then it goes to 3125, which is lockout fan after a cool call. Some people don't like the fan to still run. Just turn it off, and then the fan shuts off with the cooling. And that's pretty much it. Then you'll hit save and exit. Exit again, and then all your settings are locked in there. Right now I have my cool set to 7881 here in my shop. So it's waiting on equipment. That's the infamous delay. I said it had let's push that. It said it has an outdoor sensor, so it's got a little alert there. Because I don't have one wired in this, obviously. It's free floating. I only have batteries in it. But yeah, if you got any questions about how to hook these Focus Pros up, let me know. Last thing we're going to do is that float switch, and then I'll conclude the video. Alright guys, simple float switch. I won't waste too much time on this because it's a basic thing. So it's got 2 wires. All this is doing is breaking your circuit if this pops up, okay? So it's got this little float in it. If this guy goes up, all of a sudden this is open. Your power's in, but your power's not coming out. It'll kill your equipment. That's all it is. 24 volts. Damn fly, get out of here. So you're going to break like on a straight AC system, you're going to break your Y wire inside of your air handling cabinet, okay? Don't land it to your low voltage terminal board. You're gonna break it here. You're gonna break it to one side, and then you're gonna tie your other side to the terminal board. That way, your 24 volts is gonna flow through your float and out. If that float pops up, it breaks it, doesn't energize your terminal board, it's not going to flood the customer's house. Simple. All floats are built the same. If they're a mechanical float like this, that goes up, that opens up your switch. That's down, you're good to go. Your 24 volts will flow through. If it's not with this down, you got a bad switch. That's simple. Easy. What pushes this up? If let's say you put this on the secondary part of your coil, it's a little bit higher than the other one. Your primary drain clogs up, so the water's going to flow through here, push your float up. It's going to save your customer structure. Very simple. I'm not going to get any more in depth with that. Hope you guys enjoyed the video.